and LLMs. What we have what we have put into place is the integration of structured data, contextual documents, and LLMs in a modular pipeline. So our inputs will be a data flow in a SDMX data warehouse, context documents, for example, economic reports from World Bank, that is a handbook, let's say, of the latest 3 months on how countries are performing in terms of economic indicators. So everything that domain experts can drop into a SharePoint folder, from which we are going to perform a retrieve augmented generation and a config-driven file that will say, okay, in this report, we want to have this and that plot. We want to keep this text, and we want to use a certain prompt that we're going to ask upon this data to get certain insights. This workflow is in essence a Python code that stores in Databricks. It will pull documents from this SharePoint folder to build the vector database to perform the RAG. It will pull data from the data flow in SDMX to feed the context window where we're going to ask these questions, and use OpenAI models in Azure Web Services, which is our provider in UNICEF. All these outputs are brought together in a library that essentially is able to render this nicely in a PDF that we will push back to SharePoint, because in terms of quality assurance, we really don't want to just build text and publish, but we want to involve the domain experts in this process. And we have figured out, we are testing doing this in a semi-automatic way, in the sense that we are using an open source library called deep-eval that in essence can use the same LLM or other to come out with a score. This score will be like a precision recall kind of statistical score based on some other prompt that we put in this config file that will do either a factual consistency check or a more general test over the prompt, so as to allow the analyst to say, well, maybe if I need to read 200 reports, I should start with these first 10, which have the lowest quality scores in terms of evaluation. So, so far what I have presented is the integration then of this Gen AI into this workflow. We have devised this to do it with reusability in mind, in the sense that having structured data, today is SDG, but tomorrow could be another data flow in our SDMX data warehouse. Again, the contextual documents may change, but the core exercise there will essentially, we have devised this with reusability in mind. To acknowledge that this is really a testing, and what studies show is that moving pilot to productions in Gen AI has been only 5% of the last 2 years projects in corporations. So this is a really challenging, and what I think cross collaboration is essential. That's my opinion, particularly because our team, we are the data engineers, so like the Mario and Luigi Bros Nintendo characters. So we build the pipelines of a workflow, but we really need the domain specialists, in particular here, the fine tuning of the prompts and the capacity to take this to another steps in terms of reliability and accuracy. And with that, I leave it and over to you. Thank you.
Thank you so much, Alberto. And I agree on many fronts. If we want our data to be used, giving context, telling something about it is so important. And the context you could describe to clearly see why it is needed. Another example where standardization and SDMX make this innovation possible. And it's really interesting to see this. And hearing from you as a data engineering consultant, you need this cooperation with experts is also very encouraging, because I really believe that this cooperation makes things really successful. So yeah, great presentation. Thank you. Next one is Shutong Ding from the ILO. He's a knowledge management officer in the Department of Statistics. So, and part of the SDMX Statistics Working Group. So, floor is yours.
Yes.
Oh, you're here already.
Yes, thank you, Direct Chair. Good afternoon, everyone. Let me begin by thanking Bank of Italy and the organizing committee for having this important event. The ILO, as a proud member of the SDMX initiative, we are very pleased to be here to share one of the most impactful program that we have been benefiting from SDMX, the Labor Market Information System, LMS, and also its latest development with AI. So to introduce this, I would like to invite you to imagine with me together and to fast forward a few years ahead. Imagine in 2027, we have a labor market intelligence system that can automatically generate labor market trend insights. For example, there's a message pop up on our screen. Use professionals with the SDMX certification have a 30% chance higher to get a job. So such a system combining all the information coming from different agencies and without hallucination. And this is something that we're dreaming about in front. And today you see a sort of baby version of this where we try to build applications in AI to draft analytical reports from the SDMX data. A little bit background on SDM Labor Market Information System. Since 2018, ILO has been supporting countries to develop LMS. It's not only just about data consolidations, but also we help in the institutional arrangements on data governance and also helping to build the local capacities and champion the open source tools like Dosta Suite, which is also having the SDMX compliant. Today we have nearly 30 projects covering more than 50 countries globally. And with more and more system into production and also data perforations, we are seeing both opportunities for insights, but at the same time, we're facing the analyst challenges that how we're going to analyze this large volume of data. So this is where we motivate us to look at how the generative AI can help. Just a quick example of the LMS data portal. Here are two quick facts. One is that the labor indicators typically come with a demographic breakdown, such as like employment by sex, age, and employment by sex and education. Secondly, those information, we can easily capture thanks to the DOSA suite. It's possible to retrieve it directly through API, both metadata and data. So before designing the solutions, we run a quick feasibility check. And we know that the data we're dealing with is aggregate level, and there's no micro level disclosure, and it's well structured and harmonized. And we also can retrieve data through API. And then generative AI, very powerful, but do we have any existing AI tools that can achieve this by directly prompting? The answer is not yet fully achievable. We look at all even the super agents, but it's not. We find that they still require a dedicated AI-driven workflow and also a structured prompting, incorporating all the expert knowledge from the labor domain. And finally, we decided to go for a web application, which with minimum configurations and centralized deployment. Of course, the idea here is really try to start to draft the initial drafts. It's not the final, requires a human validation. At the same time, it's not replacing the analysts. Just to highlight, what generative AI could help in this context. It supports multilingual naturally, and also it has, they can ingest the domain knowledge and also reporting styles by integrating the reports that previously have. And also, naturally, it can draft the analytical reports, but also creating the codes for graph plots and so on. And most importantly, it can reproduce the similar tables to others, sort of effortlessly. But the results, of course, the exact results may not be guaranteed. So the final solution that we we started development from the beginning of the year, and now we have sort of prototype of the solutions where we have 3 core functions that in mind. The first one is the single table analysis, where when the users to pull from one data flow, we're able to generate the graph codes and also the report and for that single table. And then you roll out to the the overall tables that you have from the system, and the idea is to generating a sort of Jupyter notebook, incorporating with the report together with the source code for the graph. So the user are able to edit on top of that. And finally, we have dashboard templates, which is basically to creating the initial draft of the dashboard that the countries can adopt. So a little bit deeper on how we actually can achieve this. So for the single table analysis, after data retrieval, we start to reshape the data, pull all the constant attributes into a context for the model. And then we also slicing the data series and on the recent periods by random combinations of the breakdowns. And after that, we call the AI models to generating the reports, the codes for each slide. And then finally, we do the consolidation and to get the report as you see on the right-hand side, and also the graph codes and together with the charts. And the second phase and third phase is still ongoing. And this is basically, if we're able to do for the single table, we can rule out for all the tables. But here we also incorporating the knowledge by analyzing the historical labor market reports and also try to learn the tone and layout. And then we try to consolidate it as a single market report. And for the dashboard, and this is actually take advantage of what is already in the community, the dashboard generator, which is an open source tool that is using the SDMX data query in JSON. This is a hackathon winner from 2023. And then the idea is to learn from this existing dashboard JSONs and to generate a template in JSON. Here I want to highlight the key message that we're through this journey that we've really benefiting from SDMX, which is SDMX really empowering the AI implementations. So you see that we have data complexity. We try to integrate data come from different agencies in various formats. And then through SDMX, we're able to do it with a structured and harmonized information and through standardizations. And then we also have the API allow us to retrieve data up to date. And of course, for the data semantics, you not only have the data points, but it is required to have the context, the semantics for the model to understand. So this is where we can have the rich metadata thanks to SDMX. Of course, we have the global communities. The ecosystem help us to have tools like dashboard generator, the PY SDMX that we can use as an open source tool. And final points for you to reflect. We see that SDMX naturally facilitates such automations and AI integration. And also, just to highlight the one benefit from this, simply offering a product in multiple language, it could be a very costly for an organization like us, and AI just make it so seamlessly. The zero consolidation, it still remain question because we found that maybe it incorporates some knowledge by itself. For example, it interprets the graphs and the codes based on the his understanding on the COVID impact, etc. But yet to be final proved from the field testing. And there is a trade-off between AI and also predetermined programming. So we found that we want more insights by AI, then we were also increase the risk that generating by the codes, that fill the graph. And the final one is that can we really generalize our analytical core beyond the labor context into a more general context? I think this is something also enlightened with the MCP. Maybe we have to think something more in general, maybe can fit for the financial sectors and others, right? That's all for me, and thank you.
Thanks, Yutung. It's really impressive what has been achieved the last couple of years. I remember that in Bahrain, in the previous global conference, we were talking, everyone had some ideas what we could do. And now 2 years later, so many very concrete applications out there providing context, like we just heard from UNICEF or now the ILO. Yeah, so I think I'm really looking forward to the next conference in 2 years' time. I think we'll be amazed. Developments are going so fast. Thank you. Last presentation of this session is by Simona Rosnovic and Davide Rosnovic, co-founders of Inlook.ai, an AI startup focused on transforming access to statistical data through intelligent search and visualizations. Expectations are high, and the floor is yours.
Hello, we are the founders of Inlook.ai. We started by building the AI search engine for statistical datasets. And then after working for a few big statistical organizations, we set our vision higher to build the AI infrastructure for SDMX.
So how did we start by building the AI search engine for statistical datasets? Well, first talking to the users. So basically after talking to more than 100 people, we discovered that some search very broadly and some others instead know exactly the specific time series they are looking for. And what we are trying to do is basically to address both of these type of users. But we can't do this through a standard chatbot because they can't provide 100% trusted data. And if we have this standard textual chatbot, and they often require several interactions before the user actually gets to the specific time series. And finally, they also lack of a proper visualization interface. So what we did at Inlook is basically build this system in which you can type a query in the search bar and get an interactive chart, a table, and the source for the exact trend in just a few seconds. We provide 100% trusted data, and we target both broad questions and very specific questions, and the platform is very easy to use and visual first.
As an example, we worked for OECD to address 3 main priorities. Building a system which is very cost effective because they have a large external user base, so public user. They didn't want any risk of spreading misinformation, and they were mainly interested in public use again, with an eye on internal use. So the system currently working for OECD is works on all the 1,500 data flows. And for example, here we type what's the tax pressure for companies in Switzerland versus Italy since COVID time. And the system is currently retrieving the top 10 datasets first, and then refining the search to rank the really top 3 in order. So the AI is also providing a justification to guide the user in understanding if the retrieved data flow is really effective for the outline, the user query. So we see this yellow band here, which is the highlighted period, and it's the AI which automatically extracts the time range the user implied in the user query. But you can also, of course, drag manually this slider. And the source here redirects exactly to the specific data flow in the OECD Data Explorer with filters already applied. So the table here is showing the same data points that you see already displayed in the chart. So as we see also, the dimension values have already been applied by AI for each of the dimension, but you can also quickly add them manually. You can change the chart to bar chart, for example. And you can see this AI-generated description, which is often very effective for end user to just get a quick glimpse of what the dataset is about. But there's the full description from OECD often is much longer and is also here in the notes. And this is the second and third data flows in order of priorities.
So we talked about public use, but what about internal use? So we thought that the best way was simply to use our Inlook search engine and couple it with the MCP protocol. So this is very simply how it works. So a user types a question on Claude, Gemini, or ChatGPT, which have access to our tool. And this question is redirected to the Inlook search engine, which performs exactly the search that we showed before. It retrieves the specific time series, and it gives this time series back to Claude, for example, and which re-elaborates all the final result. So then, while we were doing this, we thought, wait, maybe this is a broader problem than we think, and all the people, not only people in statistics, they search for statistics on Google or ChatGPT. But Google and ChatGPT, they don't have access to official statistical data sets. So they make up numbers, or they avoid answering, as we were saw before, or they refer to articles. So you see, this is the iceberg of all data that is contained in a statistical organization. And just the pinnacle of that is visible through ChatGPT. Most of the information is contained in statistical data sets that are hidden. So if I ask on Claude, how many homicides are committed every year in the Swiss canton of Basel, this information is not publicly available in articles, so they try to make up a bit of numbers, so they don't reply exactly. Same on ChatGPT and same on DeepSeek. What we wanted to do is to really uncover all the iceberg. So this is very quickly how it works. The user types a question, how many homicides are committed every year in the Swiss canton of Basel? Claude says, oh, I have this tool, can I use it? I provide this access. After a few seconds, Inlook performs the search, gives back the reply to Claude, which re-elaborates the answer and gives back all the specific numbers. But not only the numbers, you see there are the specific notes that are only present in the datasets of the Swiss Federal Statistical Office, like the Swiss crime code notes, and so on. So, you know, while doing this, we already presented it in Geneva some months ago, and we thought we can probably make it available for everybody because everybody is using, is accessing ChatGPT or Google and so on. And we got a very strong interest from a couple of Nordic countries, but I'm turning the question to you. If we find at least five statistical organizations, we can go and propose this solution to be integrated natively within ChatGPT, within Gemini, so that everybody can access official statistics easily and in a trustworthy way. But then, you know, we talked now about the MCP, we talked about the AI search engine, but we think that you can make one more step at this point, and the future is actually here. So this is the proposal that we made to the International Labour Organization, a request for proposal, literally a few weeks ago. And basically, they had more an internal use interest with an eye for the public use. And of course, talking to them, we discovered that they really cared about their metadata, about the metadata being very precise. And so we thought maybe we can do something on that using AI. So this is the full detailed architecture that we built and is available. We have 30 pages explaining all of that, but I leave it to you if you want to give it a look later. I want to very clearly show how it works, like the whole life cycle. So we have the AI search engine, the MCP. We talked about it before. But then, you know, out of all the queries that we can collect from the users in an aggregated way, we want to understand who is searching, what they are searching, how they are searching, and if they are finding or they are not finding what they are supposed to find. And then after this, which is basically UX research, which we are implicitly conducting for OECD. But then we think, wait, we have some cubes, SDMX cubes, and they have some problems like sparseness of data. They have problems like a little, like descriptions that are not really suitable for the users, that user maybe don't understand exactly. So we can use AI to facilitate metadata refinement. And after that, eventually, we can get to simply facilitate SDMX metadata modeling. So this means that we can help drafting the creation of the cubes exactly. And this means that we are literally improving AI readiness, and we are closing the feedback loop. The next search will be easier for the users. Users will understand better. And yes, This is simply what we mean by AI-first statistical organization. Thank you.
Thanks, Simone and Davide. I think this is Unicum, two brothers presenting at the conference like this. Compliments. It also shows how important startups are. I mean, all these smart, quick technological developments combined with our statistical knowledge can be very powerful. I like this AI look. I mean, just looking at what the MCP enabled LLM gives for answer, and then how should we improve the metadata? Because this morning we said we need this good metadata and then have the access, but indeed there's a feedback loop, and thanks for pointing that out. So when I started chairing this session, I said to organizers, no way we will have time for questions and answers. I mean, 8 presentations and 1.5 hours, but we do actually. So it's not due to my chairing, but to the presenters who kept perfectly the time. So we want to make use of these 5-6 minutes we have left to ask something to one of the presenters. Yes, Eric? And then you. Yeah, Mr. First, Eric.
I would actually go to the point that Simone and Davide made on, in a way, knowing better the users. And I think this is something that previous presentations somehow hinted at. For example, Alberto, the starting point was the problem of lack of usage of data, actually. But I was just wondering, how do presenters see how knowing the users will transform the way we want to develop these applications? In many cases, the posture is also very much still supply side. I have AI, I need to make it AI ready so people can access it more easily. But then how can we perhaps switch the perspective so we really start from the user side and try to understand, how in a way users will be different, even will cognitively evolve, if you like, and how their needs, their way of using the data will evolve, and how we can be driven by that. And so here, is there a sort of switch of perspective that we should also be thinking more about? Thank you.
Yeah. Question here in the front. Here.
Thank you. This is Wei Chen from IO. Thank you for the presentations. It's really eye-opening and a lot of inspirations. But my question is about the metadata in the SDMX, especially for those people who has implemented certain solutions using LLMs targeting the SDMX APIs. Like, my understanding is that no matter how smart the LLM model is, eventually you are still tagging the metadata in the SDMX. So you depends how you organize your metadata in your SDMX API, depend how these informations, like, is it complete, and or there's a lot of redundant information that could happen in the SDMX API. So based on your experience, like, how do you see the effort of creating the AI solution and the really managing and refining the SDMX structural metadata? Like, what is the balance between these two efforts?
Any other questions? David and Simone, I think it's really on your area, right?
Yes. So regarding the metadata, yeah. In fact, so I like, we personally think there are really 2 points. One is, of course, like, AI cannot know everything about what the data flow is supposed to be if that information was never written before. So basically, there are some things that AI can directly put in front of the, let's say, an internal administrator, and the internal administrator should simply click confirm, because sometimes the metadata is simply not there, but should be supposed to be there, and it is easy to just, it's simply like retrieving something. For example, I don't know, there's maybe a description for a specific dimension, value, name or dimension name, and sometimes it's mentioned, sometimes it's not even mentioned. So in some data flows are complete, some are not complete, but nobody knows why it was never written. So that case for AI, like it's very easy. The information is there. You just have to basically clean the surface and such that each data flow has the same information and it's complete. So that is something that AI can fully do, and the administration will simply click, okay, okay, confirm. And then there's another part. Another part is, let's suppose that some data flows should have some information, but it was never written in the first place. So in this case, AI can guide the administrator in understanding first that, okay, something should be maybe improved, because sometimes something is present, but it's very concise and not enough. So help the administrator understand that it should be improved, and with some very specific suggestions on what could be written there. And it should be responsibility of the administrator to say, okay, I'm the expert here, or I should take the expert in here. And according to AI suggestion, okay, AI is telling me, okay, maybe some specific more information about this labor system code should be required because I saw it in the other data flows, but I don't know as an AI what you should write here. Okay, but you should add something here. Okay, then I call an expert. Okay, the expert should say, okay, the code is this, maybe add this here. And so it's like, in this case, it's AI guiding with specific suggestions on how to improve, but the administrator is still responsible for this. So these are the 2 points.
Thank you. Julia, you want to come in?
Yeah, so as a general rule of thumb, but I think it is what they experience as well, the most critical metadata information is exactly the metadata that the AI cannot produce by itself. So if the metadata can already be automatically produced by the AI, that's not the most critical one. The critical one is the one that you have, but the AI cannot guess.
Yeah, maybe to address your point around users, I think in UNICEF, working as a global team, our, let's say, business users are the country offices. So at least in this exercise, these are the guys that gonna sit to a ministry or to a government. So in our next step, or what we receive from them is that if we present to them a country brief, then they will actually think this is useful, but we cannot scale, right? So this is something that we trigger back, and sometimes we don't think. But yeah, essentially, it should be definitely part of the process, and maybe in the UN organizations we don't have that much incorporated that part as in the private sector, where you have let's say you have a lot of clicks from users where you can act upon. Yeah, definitely that's part of the loop that we need to close back, and this is something in our part. It's not only the collaboration across our teams, but also once we have some input back from at least from us would be country offices, so country representatives, unit chiefs that are the ones that are this product will be valuable. So yeah, I think I take your point as something for us to commit in our everyday work, I would say. Thank you.
Thank you. Is Jens, Lisette, or Alex, Rafael, Bianca want to comment on the questions on users? And I just want to give the opportunity. Thank you so much. It's really energizing to see. You do. Okay.
I actually do have a question for all the speakers in the room, and myself included. So one of the things that I notice is that there is some level of redundancy in our effort. I think that I've seen at least 3, if I'm not mistaken, MSP being developed. I've seen various attempts overlapping, which is great. It means that there is a lot of different solutions already found, different problems already faced and solved. Should we try and converge? Should we try and make things together?
Yes. This evening, we have a STMX sponsor group steering committee, and this is exactly the topic. I mean, when things go so fast, like the MCPs, they were not delivered so long ago, and already today we see 3 applications. It's good that we exchange things like we do now, and now we have to see how we work together. And it's not bad that there are different applications that can exist next to each other, but the basic, how we make STMX AI ready, what we mean by that, especially the semantic and the context part, is really great to work together. So I think the STMX community is a great place to do that. So that's why, for example, the IMF wants to put ours, that GPT product, in there, like other product, like what the BAS presented on their approach. And then we can really work together, share tools, etc. But in this stage, it's not bad if there are different experiments, people doing similar things, and conference like this, and the steering committee will bring those things together. But it's a great question. Now I'm going to conclude because we need coffee. It's really energizing how much has happened. And it's also great, the development. I said it before, 2 years ago, there were many ideas. Now there are many things realized. And I think in 2 years' time, we'll be amazed what has happened. So we're statisticians. We're trying to make data that matters. And in order to do that, we have to provide context, like Shutang and Alberto described. We have to make data found where people look for it. So we have to ensure that where people look for data, search engines, chat box, our data is there on a good way. Don't give away our data, but make it accessible in a way that still is a large distribution and a good use. And I think we together can do it. The STMX community has shown that, and I'm really optimistic and positive how we will take this forward. Thanks to the speakers again. Let's give them a round of applause.
We should make that for that, so you have to carry that.